Hoffman, Everyday Spacer.
I'm Jeff Miller, 2049 Outfitters.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, which is 2 p.m. on Saturday in Queensland, Australia. We're broadcasting live from Thousand Oaks, California. Tonight's topic, Solar Active Region Spotter. We'll be back in 8.3 seconds. Tonight, our topic has changed. Jeff planned to demonstrate Galaxies Do Weird and Wonderful on Zooniverse. It's a citizen science project. However, they finished the project since we announced it last week. For this citizen science project, you can help track active regions as they evolve across solar rotations. In other words, you look at active regions to see which are new and which are returning on the sun. Thanks so much, Jeff. Take it away.
Okay. First, I'd like to say hello to
hello.
Shuji. I hope I'm not massacring that name too much. She got here early, actually very early, then she came back. So welcome.
Welcome.
And Janie Becker.
Hey, Janie, welcome. Happy Cinco de Mayo.
Yep. Yeah, for all of the different things that were happening on the 5th, that's one that we didn't post. And I thought about it earlier today.
Maybe they'll do margaritas in space. I know there's a glass already designed for it. So
yeah. Now, last week's topic was in the high 80s in the percentage for completion as of Friday when we did our show last week. And now yesterday found out it was done. So mad scramble, and we found another good citizen science project.
But I actually think this one's a little more interesting. It's the other one's very cool. You gave them your opinion. This one is kind of more sciencey, and you can help out.
Yeah.
With sunspot. So it's solar activity, right?
Yeah.
Oh, hello. Hi, Dawn. Welcome. Glad you could join us.
Yeah. Hey, Dawn.
Alrighty. So, do you want me to share the screen yet? Or
yeah.
You ready?
Ahead.
Okay.
Go for it.
Let's see. There it is. And I'll also give the link for this one too.
Yeah.
Cool. I'll put it in the chat.
Yep. Okay. So NASA talked about this, although we didn't find it from the NASA site. I just found it from Zooniverse. And, so this is just, a link to the NASA site, and they have some other links in here. But the actual site itself is, well, this should look familiar to anyone who's done a Zooniverse project.
Yep. We've covered a lot of them.
Yeah. So about classify.
Boy, those run all together. That's interesting.
Yeah. Well, that's because I've got my screen pretty zoomed in.
Oh, I see. 150%. Yeah, got it.
See, if I zoom out like that.
Okay.
But it's easier to read on other people's computers if I keep it zoomed in a little bit more.
I think we changed it back because it was going in a drop down, but.
Right. And I like this better.
Yeah, that's more understandable.
Yeah. So it's helped them track active regions as they evolve across solar rotations. And that's the important part, as we'll learn in other portions of it, and they'll give more detail.
Oops, I was going to share both of us. Where'd it go? Oh, there it is. That one.
Oh, yeah, you've got that very small over there. Basically, NOAA, NOAA, tracks all new solar flares numerically, starting with at the beginning of the year with 1, 2, 3, whatever. The trouble is that they don't distinguish between a solar activity that begins like mid-sun, as the sun's rotating, or on the edge of the sun, meaning it started at another point and is just rotating around to us. So they could have active regions that have lasted more than one rotation, which is about 27 days. And so what they want us to do here is distinguish between new events and events that um, resemble something that happened on the previous rotation.
Okay.
And so that's, they basically look at the same time because they know how fast the sun rotates. So they just match times on it.
Sounds like something that because of course people are really good at pattern recognition.
Mm-hmm.
Are they using computer?
Yeah, I didn't see anywhere in here that they're using computers for it. They might be, but I don't think so. Just because for one thing, one of the portions in here, they say, don't worry if it feels like you're just guessing, because they want your instincts in it.
Okay.
Because
that's good.
Some of them are
hard to replicate by a computer.
Yeah.
Instinct.
Yeah, and sometimes you pick up things subconsciously that you don't.
It's true.
Yeah, and so there are many objective ways of telling whether it is or isn't, but there's a big gray area that things can fall into, and that's probably what they need us for.
Boy, it sounds interesting.
Yeah.
You ready to demonstrate?
Sure.
All right. Let's see. Let's get that one back up. Here you go.
So here's the website. Everyone. Now these are the pretty pictures. This is what draw me to it. All of these pretty pictures. You don't really use these pretty pictures a lot. They are there for each one, but we'll get into it. These are just the sales pitch. Really pretty pictures. 6% complete.
Yay.
Yeah.
So there is still something for you to work on.
Yeah. Well, and it's less than 10%. Well, okay, yes, 6%. But if you can see, 856 subjects, and only 50 of them, or 58 of them, have been completed.
Okay.
And basically, this is a little bit about it. Helping solar physicists to be able to study the long-term evolution of explosive regions on the solar atmosphere, and that's why we're looking for long-term versus short-term stuff or recent stuff, because they want to be able to track things that have done more than one rotation.
Okay.
Just to see how they evolve.
Cool.
Yeah. However, as the sun rotates, when an active region enters view, it gets a new name, whether it's actually a new active region or one that's returning. So this is, they're trying to sort out the NOAA data.
Okay.
And make it make actual sense. And maybe they're trying to provide routines that help NOAA, classify these things as returning.
Cool.
I don't know. They don't say that, but I would hope that they do, because that would make the NOAA data even more useful.
And it might be in there somewhere in the forum or the statements by the the people organizing this or whatever. And sometimes they refer to other sites. We just had to switch gears last night.
Yeah.
We'll do our best here to demonstrate the site, and definitely look into it for yourself as well if this sounds interesting to you as a citizen science project to work on.
And some of the images are black and white, but they won't show them here. This is interesting information about, they talk about what things are. If you know anything about solar physics, this is basically review, but the eruptions come from, plasma, which are charged gases into space along magnetic lines.
And you know what? I have a link to this thing, and I forgot to show it. But if you go to Zooniverse and you look for solar active region spotter, you'll be able to find it. I think they have a search thing in there.
So the main instrument that we're using here is the helioseismic and magnetic imager.
Oh, cool.
And
that's the one that NOAA works with?
Right. Well, they work with these three. And so there's two instruments that we're using, but the main one that we're using is HMI.
Oh, I see.
Okay. The AIA is the one that makes the pretty pictures.
Okay.
Which are useful, sort of, but they're not. They say that they're not as good for finding things as. And what they do is they take UV light in three different
Oh, wavelengths.
Temperatures, wavelengths. Yes, thank you.
Wavelengths.
The word was gone. So 3 different wavelengths, and make a false color picture of it.
Okay.
And
yeah, a lot of the pictures are made that way.
Mm-hmm.
I think they just assign a value,
Yeah.
color value to a wavelength, and then they present it all.
Yeah. So
depending on the wavelength.
So the blue is not blue. It's just the shortest, or that's the shortest of the UV wavelengths.
Of course, because we see invisible light, so
yeah,
that's why they transform these into beautiful images for us.
HMI makes grayscale images.
Oh, very good.
Called magnetograms, and these are what we're really using. And they show active regions as strong irregular shapes in black and white to denote positive and negative. What's that? Oh, hey, Scott.
Welcome, Scott. Good to know.
Yeah, Scott, this will take more thinking than counting craters. I'll tell you that. And a lot of judgment. It's gonna.
Oh, interesting.
If you want to get into it, it's
Alrighty. Okay.
So black and white to denote positive and negative magnetic fields. And the way they get the magnetic fields is plasmas emit light in a very specific frequency. When that light goes through a magnetic field, positive and negative magnetic fields split the light differently. Like the light is spread more in one than the other.
Okay.
And I forget. We'll see in another section which one it is.
Okay.
But that's how they determine. So black is positive or negative. I don't remember which. And white is positive or negative. Gray is no real difference.
Oh, okay.
So that's and here it is. The Zeeman effect.
Oh, interesting.
Energetic. So this is just basically what I said. I just didn't realize it was so soon after I was talking, or I would have read it to you. So that's how you get the magnetic footprint.
Alrighty.
And so they're saying that that's the primary way. The plasma, which is so magnetic fields is what the HMI looks at. The plasma, which emits UV light, is what the AIA data looks at.
Okay.
And definitions, if you want to learn what the things are called on the sun.
Very good. Yep, that's the beauty of these too, is that you can learn a lot of different things.
And the team is not huge.
Oh.
Emily Mason is the lead investigator. She started out as a citizen scientist in college.
Oh, neat.
And has almost 2 decades of experience in science outreach.
Very cool.
And Kara
Nizuski?
Yeah, we'll go with you. Midshipman
Nizuski.
That's
my guess.
Is the resident lead subject matter expert in active region spotters.
Oh, very good.
A senior at the U.S. Naval Academy. She's already produced a publication on solar flare statistics.
Wow.
So, and so
here it's just the 2 of them. Okay.
Yeah.
And there's more. Okay,
and
I see.
DJ ARB, I don't know. He's a collaborator. So
all right.
He's helping. Don't know why he gets top billing when the next 2 are actually, it's in a reverse order of who's in charge of what.
Interesting.
And the fact is, what's a corona? What's an active region? Why are active regions important? Because those are the things that spew stuff like CMEs.
Yes.
Explaining.
Yeah, we were just tuned into something on Curiosity Stream, and they mentioned coronal mass ejections, which can be a real problem for power grids. Actually.
Well, in fact, for anyone who's a sun watcher, we're heading into solar maximum. So.
Yeah, we're nearing the peak apparently, and I've been out a couple of times with the filters, and I have definitely seen sunspots, which I haven't seen for a very long time. Yeah. Plus, it's been quiet. There's kind of an 11-year cycle.
Right.
They come and they go, just like everything ebbs and flows.
Oh. She says hi again, or he. I have no idea.
Yeah, go ahead.
So, what are the grayscale images? And we talked about that. They just say it in more words here. And so that's the about.
Good. Yeah, plenty of stuff to look at and learn.
Yep.
If you so choose.
And here is where you know it's going to get hairy. There are so many steps.
More than 3.
Yes. And this is what the black and white images look like.
Okay.
Positive and negative.
Interesting.
And these are 2 different active zones in the same shot. And just so you know, they'll talk about it later, but this is a younger one than this.
Oh,
because they start off close together and bunched up.
Okay.
And
smaller
this one
too, or
yeah, basically the regions are smaller and then they spread out over time.
it's gesturing.
Yeah, so they spread out over time and they get farther apart. So
Okay.
it kind of does this.
Okay, and this is, I take it, the exit and the entry, the re-entry part.
No.
Oh, okay.
Well,
Well,
yeah,
let us know.
yeah, black plus white. They don't say, but I'm going to assume that exit and re-entry in here.
Okay, Shijuzi has what's the content? We are talking about, what's it called again? Solar Active Region Spotter.
Right.
They want people to come and visit the site and look at the pictures and try to make an assessment of what they're seeing. And Jeff is describing the actual process of it right now. We're demonstrating this citizen science project for you. Stay tuned.
Yeah. So yeah, just in case you're here recently, they're trying to determine which solar events are new ones and which ones are basically have been around the previous rotation.
Okay. Very good.
So here's where they talk about black is negative, white is positive, and gray is a weak field, not strongly black or white.
So what is it? Black's negative, white is positive.
Yep.
Okay.
And I don't think it really matters for what we're doing,
Okay.
except that, that's what they are.
That's interesting.
Yeah. And, there are 2 active regions circled in red. And
in this particular image.
Right, yeah. And they say that the upper right one is newer because the black and white are closer together and compact. The larger active region has much more separation between the black and white, and the field is more spread out.
All right.
These are signs of an older region.
I like it when it's nice and clear like that. You understand what they're saying.
Yeah. So here's another image, and this is an example of uneven decay. There's a strong concentration of the black here, but the white's all spread out.
Ah, okay. This is fascinating.
Yeah. It's a good indicator that this active region is pretty old.
Yeah, it kind of looks like it's older, I would say.
Right, yeah.
They're much more spread out.
Mm-hmm.
And what's they talk about more circles. Are you circling several different things here?
No, this is they're just circling these to show us.
Okay. So they're telling, okay.
Yeah, they're doing the what, not the how yet.
All right. Very good.
So here is what we're actually going to be looking at. New frame, old frame, and basically comparing the 2 and seeing if what's in here looks like, actually old frame, new frame. Basically, or do they look like the same event, just different in time zone, or are they 2 different events?
I feel like they're 2 different events.
Yeah, although this one is more spread out, but it's in roughly the same area. But yeah.
Mm-hmm.
So let's try looking at them without annotations. So yeah, this is looking at the raw images. The image on the left is the original active region, and the movie, and this is a movie, not an image.
Wow.
Is the candidate active region. So as it changes over a few days, this is just so in this example, it's not moving because it's just a screenshot.
Yeah.
The active region in the still image on the left should look like it has a stronger, more concentrated magnetic field compared to the active region on the right. and it does if they're the same.
Yeah, I would say it does.
Yeah. The movie on the right should show the black and white fields moving away from the central mass concentration and fading. If this isn't the case, they're unlikely to be the same active region. So the movie should show these spreading out and getting farther apart.
So this looks like that you have quite a bit to sink your teeth into already, and we're only partway through.
Yeah, we're
about a third of the way through.
Yeah, a third to a quarter of the way through. Oops.
All right.
Yeah, and here's where, of course, there isn't always a strong or concentrated field to begin with. The example above shows one such region. See, it's kind of spread out.
Nothing real focused. Yeah.
Yeah, it could be new but weak or old and weak active region.
All righty.
The regions like this are unlikely to have matches. So either it's a new and weak active region and isn't likely to last a whole rotation, or it's already old and it's unlikely to have another rotation.
Okay.
So these should be categorized as not matches. So if you see something like this, you don't really have to go much further than that. Okay. Now this is where you look at the pretty pictures too. They're pointing out two different things here. This and this blue region here. An example you'll see on the magnetograms, the image above is what we call a EUV composite, 3 different wavelengths. Okay, they're just saying that what we saw before. These are supporting data only. They can help you decide whether 2 active regions are the same if you're on the fence, but are not reliable as a primary source to make the decision. Plasma in the corona changes and moves much faster than the magnetic fields on the surface do, which makes the EUV images more dynamic and less likely to look similar. 2 main ways the EUV composites can help you make decisions. Look for obvious blue regions that remain in roughly the same location in both images. And this is what they look like here.
The dark blue regions.
Yeah, the dark blue. These are coronal holes, which are other long-lived features on the sun. So therefore, they make good landmarks because they're likely to last through a rotation.
Okay.
Dark snaky areas, I'll show that to you here, this little
I see.
arc there, are often near the brightest parts of the active region and appear in both images, indicated by the purple arrow. These are called prominences, which hold lots of relatively cool plasma and last for days to months.
Right, and prominence is something you hear about a lot when it comes to solar flares.
Yeah, this is mainly what you see when you're seeing pictures of solar flares on the sun. That's what popular press generally shows you. But in these, they're so overshadowed by everything that they just appear as a shadow across stuff.
Wow. Well, it's a temperature thing too, right?
Yeah.
They're cooler.
Yeah. Because of course they're not in the sun, so they radiate a bunch of the heat.
Right.
And
more pretty pictures.
Yeah, side-by-side pictures. Here's an example of how a prominence can appear from different angles on the sun.
Oh, it's the same prominence, but it's...
Yeah, as the sun rotates.
It's moved around.
Yeah, as the sun rotates, yeah.
All righty, that's cool.
This is the same prominence in both images, but because the viewing angles aren't the same, they can appear very different in the 2 images.
Well, it's a great tutorial.
Yeah. And it's a great way to learn about the sun, too, whether you do the project or not.
Right.
There's a lot of interesting stuff here. It can, for this reason, you're only asked whether there's evidence of a prominence in either or both images. You don't have to decide whether it's the same prominence. Just answer whether you see this type of dark rope-like signature anywhere in the bright cores of active regions.
Okay.
So this is just something, this is probably one of those side things that as long as you're looking at the data, let's try to spot these too.
Okay.
Just because there's probably some other scientist that's looking for these.
So let's see, we've got quite a few things to think about already. And we're only halfway through.
Yep.
So we're trying to determine, are these 2 about the same activity? And do you see the prominence in there? Is there anything else? Just the 2 things already?
2 things that they've already given us 2 ways of determining whether they're the same.
Okay.
The blue patch,
right.
and whether they look like they're getting bigger and farther apart in the different images.
Okay. So let's see the rest. Sounds amazing.
Okay, so here's another prominence. You see this snaky feature?
Oh, interesting. It's not in the bright region this time.
No, but it's in the brighter region.
Yes.
And you can see that this is probably where it's coming in or out, and it's going this way, probably to here, but hard to tell. This is a little bit, these two different arcs, they're the same prominence.
Okay. Yeah, and they follow magnetic fields.
Right.
So they're flowing along.
Yep.
They're following that
Yep.
between leaving and then re-entering.
Yeah. And so another example of what a prominence can look like, dark curvy structure indicated by red arrows. These frequently look stringy like this, generally have well-defined edges.
Yeah. Okay.
Yeah. So.
Very good. Wow.
This is a bright region, and you can see the blue, where essentially it's a hole through the corona.
Right.
Here's an example of an active region with no visible prominences.
Oh, okay.
Of course, just bright with no clearly defined dark lines.
I thought there were kind of, like there's sort of an arc below the very hot, the very bright spot in the middle.
Oh, you mean this?
Nope, higher up there, right there.
No, this is just normal darkness. It's not a snaky line, because a snaky line generally begins on a bright spot. Okay.
Oh, I see. Which makes sense.
Yeah. And you'll see a set of 4 items. And so this is how it'll actually look, these images. So
this is the task. This is
an
example of the task.
Yeah. And so you're comparing these two just to compare them and to look for prominences.
Huh. They look different to me.
Yeah.
Oh, okay. And now we see pretty clearly that these are the ones that were different from before even.
Right. Yeah. So, the original active region is in the left column, candidate is in the right column. Just decide whether the active regions are the same region or not. And let's step through the questions. So this is the actual process. The red annotations have been added for clarity and won't appear in the actual cases.
Got it.
So, but this is an interesting way to look at it. They're drawing a line through them.
Right. Through like the center of
of
both of the
white and black.
Okay. Yeah. Positive and negative.
Look at the 2 magnetograms. Is there a more concentrated patch of black or white on the right-hand side of both active regions? Yeah, there is. That's not, clear indication, but means if they're swapped, then it's definitely not the same one.
Got it. Yeah.
So we can't say no yet.
Okay.
Yes, there is. The most concentrated patch is black on the right side of both regions. You select black on both images. So
this is already one of the tasks.
Yeah, this is one of the tasks. This is more concentrated here. This is more diffuse. So black on both images. I guess this is more concentrated, but that one's hard for me to tell.
Yeah.
Look at the
and again, like most of these, I'm sure they're going to have a number of people looking at the same image, and if they get the similar comments and results, everybody's kind of corroborate each other. If they get very different, then they'll probably look at them again. Right.
And if everyone's got different opinions on it, that gives them something to look at.
Right.
It's a, if everyone agrees on something, then they don't have to look at it. They just classify it. If you got a bunch of opinions, then they have to look at it. So.
Yeah, I can see it as a way of sifting out which would be the more important things to look at first, prioritizing things. They may eventually look at everything, but probably look at these ones first that people are not corroborating.
Right. Yeah.
So, yeah.
So the next one is look at the 2 multicolor EUV images. Can you see one or more prominences in the active region? And we're looking up here, and hard to tell in this size. So I'll just read what they say. But If you look, notice there's a blue region here, but not here.
Right.
And since these persist, it's an indicator that these probably are not the same. But
so the images on the left are of the same thing, though they're in different views.
yeah.
And then the images on the right are the same thing. They are in different views as well.
The images on the left are the original.
Okay.
And the next ones are the next time that spot of the sun comes around.
Got it.
And I guess their computers already sorted out, like, is there stuff here but not here? Then they don't even show it.
Oh, got it.
But I don't know yet. Because we just pulled this together yesterday.
Yes.
So there is a dark, well-defined stringy signature right in the middle of the brightest part of the active region,
right
on the left, circled in red. So here you can see.
Yeah, kind of a curvy,
hard to see in this
curvy thing there. Yeah.
And there's none here.
Not really, no.
Just the normal light and dark.
Yes.
So there is a, but not on the right. So you would select yes, but only on one.
Very good.
You don't even have to say which one.
Oh, okay.
Third question. Do you think the active region in the movie on the right could be an older version of the image on the left? So that's where you now have to. So you've decided, is there one side or the other more clumpy than the other? And now you're seeing they're finally asking, is it possibly the same? And while this only shows a still frame of the movie, you can see that the active region on the right is much more spread out and weaker than the one on the left. That's more promising. That's promising. The angle between the white and the black patches is very different.
Right.
Rotation of the active regions can occur over time, but it isn't usually very pronounced. So a big difference like this is a good sign that it is not the same active region.
Very good.
Furthermore, the white arrows show that there's a dark blue signature on the left, but not the right, which we saw up there.
In the
already.
top images, yeah.
And here, let me show that again. Here, right here.
Yep.
Here, but not there.
Yeah.
Which means that probably not the same. And so, you should probably select no for are they the same region.
Yeah, they don't look the same.
And that's where
between all the different things, they don't look the same.
Yeah. For some reason. Yeah. Okay, I thought there were 4 questions, but they're just talking about 4 items. Okay. So, next one.
We are learning as well.
Okay, new set.
Yeah.
Now this could be, again, you don't look at this first, but here's a patch. Here's a slightly dark patch. Don't think so, but hey. But
it's interesting. They want you to look at the bottom images. Why didn't they put them on the top? They want you to look at them first.
I don't know. Yeah. So let's do.
That's something you could ask in the forums.
Yeah. Look at the 2 magnetograms. Is there a more concentrated patch of black or white on the right-hand side of both active regions?
Sort of.
Yeah, sort of. This one's not straightforward. The active region on the left is already quite patchy. So you may suspect from the beginning that whatever's on the right won't be a match. To complicate matters, on the right, there's not 1 but 2 active regions.
Right.
When this happens, consider the active regions that's closer to the original active region's location on the y-axis.
Okay.
In this case, that's the active region on the top. Both the active regions show predominantly white on the right. So you would select white on both images in this case. Because
it's possible the one of them could have dissipated completely by now.
Or is new.
Oh, I see. Or is new.
So if you look at,
yep,
that's.
Those are the 2 that are in the same.
Right.
What's that? Sort of latitude.
Yeah. Look at the 2 multicolored EUV images. Can you see one or more prominences in the active region? And really hard to see on something this small. So
Yeah, it doesn't really look like it to me.
yeah, I don't really see much there, but on both images, there are no well-defined. Okay, good. So even that small, we can't see anything. So no, neither has a prominence. And then 3, do you think the active regions on the movie on the right could be an older version of the one on the left?
Ah, okay.
As we already pointed out, the left-hand active region is quite spread out and weak, so it's highly unlikely that either active region on the right is a match.
Mm.
Furthermore, the signature on the much more compacted or is much more concentrated and compact on the right.
Right.
So it looks like some new active regions have appeared.
Mm-hmm.
So select no. It looks like like a new active region has emerged in the same area as an old active region. So that gives them something to chew on because they know that a new one's there.
And one of the things I really like about this is that, anytime you're playing with these, you're working with them, you can pop up the tutorial again. The field guide is there for you to check on things as well. So yeah, these are usually very well constructed and very helpful to you in processing the tasks, and doing the tasks.
Yeah, so here we go. Another one.
This is our last slide on this thing, right?
Yeah. And usually the last page is a thank you for doing this. Nope, the last page on this.
More tutorial.
Yeah, it's more tutorial. Wow. Yeah. So every single one of these dots is learning something.
Not, that looks a lot
not
like
an intro. Yeah.
Yeah, that looks a lot.
Yeah.
A lot like each other.
And here this line is almost exactly the same.
Yeah.
And
that's pretty complicated. Wow.
Yeah. Finally, look at a good example of a match.
Ah, very good. Okay.
The 2 magnetograms, that's these. Is there a more concentrated patch of black or white on the right-hand side of both active regions? Yep. That's definitely more concentrated and that's way spread out. Again, that's more concentrated and that's kind of spread out. This is aligned at a pretty steep angle marked by the line. But the white is more to the right on both. So you would select white on both images. Look at the 2 multicolor EUV images. Can you see more than one or more prominences? On both images, there are no well-defined stringy dark patches. So as we can see,
right?
Yeah, you can't really see any. And do you think the active region in the movie on the right could be an older version of the one on the left? There's 2 active regions shown in the movie still on the right again, and as in the previous example. So we've circled the one that's closer to the original, because remember, you're looking for this way.
Kind of a latitude thing.
Yeah.
No, what they call the
one. Yeah.
Which axis? X or Y? I forget.
Yeah. Y-axis.
Y-axis. Okay.
Yeah. And so the black is certainly disintegrated even more than it was on the left. Furthermore, in the EUV, you can see that there's a dark blue patch in the same location in both images, which is further evidence that this is the same active region. So go ahead and say yes. And here's where it says, many times the cases won't be clear cut.
Yay.
And you'll feel like you're guessing. That's okay. Go with your gut when making these selections.
Very good.
It's a tough task, even for professionals, but together we can figure it out. And let's get started. So
that is awesome.
Yep. Now the field guide is of use, but they basically just have examples of positive matches.
Oh, interesting. Sometimes these are very extensive.
And apparently it won't show the videos in there. But so
well, I think you have a lot of stuff blocked, so they might show up on other people's.
Yeah. I go for security stuff. So.
Yeah.
So
well, that's quite a bit of information, and that looks like some.
Right. So these
some of the videos are working.
Yeah. So that's some examples of matches, and these are negative matches.
That looks useful.
Yeah.
So it doesn't even look like it's the same from the tutorial.
Right.
It's even more.
Yeah, they've got more examples.
More examples. Very good.
Yeah.
Oh, this looks like a great project.
Yeah. So.
You're gonna show
classifying.
us. Yeah. Gonna show us a live one.
So here's the pretty pictures that you're not supposed to use yet.
They really should be on the top.
Yeah.
These 2 should be on the top.
So here is, oh, let's play this. Let's just see what it looks like.
Oh, neat. 4 seconds. Wow.
Yeah. So that's what it looks like as the patch is moving past you, because the sun's rotating.
Yeah.
Task. Look at the two magnetic grams. Is there a more concentrated patch of black or white on the right-hand side in both active regions? And I don't know why they only look at the right, but I don't know if that's more concentrated. What do you think, Pam?
Yeah, well, it's they both have, stuff on the right.
Right, but is this more
the same one.
concentrated than this? That's the.
Oh, I
This
see.
is definitely more concentrated.
Yes, right. Yeah, I don't know. I guess you have to guess.
Yeah, that's why I'm asking you. Otherwise,
yeah, I'm gonna go with no. And if you weren't so zoomed in, these might actually appear next to, right?
Yeah. So
if you see something different, that's all I'm saying to people in the audience.
it is white here.
Yeah.
White. Let's just go with it's complicated.
Yeah, I think it's complicated.
Next.
Alrighty.
That's
good because it actually kind of tells you. So just do it step by step, and it'll help you lead you on. 2
multicolor EUV images. Can you see one or more prominences in the active region? Let's take a look. I don't see any there.
No.
And I don't see any there.
No.
I also see a blue patch there, but not there. So
yeah, but they kind of evolve, so it might be gone by then.
So neither has prominences.
Right. I can agree with that.
So next. Do you think the active region in the movie on the right is an older version of the one on the left?
No.
I mean, yeah, because here that doesn't look the same.
Yeah, they're pretty different. I think they're different enough to be not the same.
So do we think that a new active region has emerged?
Oh. This takes a little doing, I think, to understand that part.
Yeah.
But it does lead you through it. That's kind of nice.
Yeah, so I'm just going to say no.
Yeah, I wouldn't even worry about it. Just use your best.
Next one.
Whatever you think, do your best, and it'll be fine.
So this is here, and this is.
There's a couple different things on the on the video side.
Actually, I think we're comparing this to this right here. There might be actually 3 active regions.
Yeah, I see that.
Except that this doesn't really look like anything here.
No, it's well dissipated if it's even anywhere near related.
Yeah.
Boy, this is interesting. So what are the choices again down at in the task? Black, white, complicated.
It's definitely white in both images. Yep, the white's more complicated, and it's on the right. So that's.
Yep. Okay. I was going to say it's complicated, but that's why they have a lot of people doing these, so they get sort of a consensus after.
Prominences. I want to find a prominence, but I'm not finding one there. I'm not finding one there.
One of them, there's something that kind of looks like it.
Where?
Yeah, right there.
No, that's part of the structure.
All right.
No, it's gonna look like almost someone drew a Sharpie over it.
Okay.
Not quite, but.
Well, you've studied this more than I have.
Yeah. So. Yeah, and I've actually seen some. I'm just trying to show the audience one.
Right. Yeah.
Haven't.
We got to find one first.
Yeah. So. No, neither has.
Yep. Let's go with that.
Okay. Do you think the active region in the movie on the right could be an older version of the one on the left?
Maybe.
For
one thing, you got those 2 new things popping up, right?
Right, yeah. But we're only really looking at this, which... Yeah, I don't think that these are older versions of this.
No, certainly not.
So this, I don't even really see this as anything.
Okay.
So I'm going to say no. Actually, new active region has emerged because.
Yeah. Yep, I like that answer too.
Yeah.
Oh, and again, so need some help with this task. There's
Yep.
a button right there. If you want some help, just click on it.
Yep. Let's see what this gives us.
Yeah. Oh, I see.
Oh, again. Let's see if it's new.
Sometimes it goes to the forum, I think, doesn't it?
Yeah. Active magnetic fields tend to orient themselves east-west as they travel across the sun's surface.
Ah.
And the field that's more to the east, which is actually on the right side of the sun, on the right side of the sun, is called the leading polarity.
Okay.
And it's important to know whether the positive or negative is leading depending on what time of solar cycle it is.
Oh, wow.
So that's why they're asking.
Yep.
Because it looks like they're looking for a whole bunch of different pieces of data here.
Yeah. Okay.
So probably more than one study is being helped by this.
That makes sense.
By looking at the same set of images.
Yeah. Why not?
Yeah. So.
Well, cool.
So. Okay. So. Again.
Well, that looks a lot like the last thing, the little video.
Yeah.
You can slow that down too. It looks like you got speed 1, half, quarter.
And they have sound, but it won't play on my computer.
They have sound? Interesting.
I don't know. I don't have speak.
Yeah.
Oh no, they don't, because you can't turn that off.
Right. Yeah, I didn't think they would.
I didn't know how they could, but
yeah.
Hang a microphone off of our settle.
So show us the question again. It's question number 1. Look at the 2. More.
Do they have concentrated black or white on the right hand side?
That side's just
this one definitely.
Yes.
This one, if it's 2 different regions, then yes. Take a look. Region.
Yeah, and maybe 3.
What the heck is that? I don't think that they're a match.
No.
Let's take a look here.
Oh no, that looks very different.
There's a dark blue here, but not here.
Right.
Oh, and here we go. Maybe, I don't think so it is though, because usually the prominences are coming from these areas.
Yep.
This looks an awful lot the way a prominence looks.
Okay.
But it's not in the right spot. So.
Yeah, I'd pick it's complicated.
I'm going to say it's white on both images.
Okay.
Because it is. It's just that I don't think that they're a match between the next part.
All righty.
Prominences. Nope. We already saw that.
Yep.
And I think that it's new active area in the same image. So there. That's pretty much.
Well, I kind of like this because it gives you a pretty good idea of how quickly you can kind of get acclimatized and really understand and work with these. And
no problem.
I mean, we've only done 3? Have we done 3 of these?
Yeah.
And we're already starting to get a feel for
all
the different parts. It sounded very complicated when they're explaining it, but I think it's a pretty decent, it's not too simple and it's not too complicated to actually execute the task.
Right. So, they broke it down into 3 very distinct steps.
Yeah.
And I think that helps a lot.
Right. And when you're doing them, it's pretty easy to figure out. Well, very good. Thank you so much, Jeff.
Oh, you're welcome.
I really learned a lot because I didn't even have a chance to look at this. Jeff was getting ready for the show. I've done other things on our list here. So
because it was yesterday that we found out that
like late last night
that the thing was done. So
which leads us into actually the stellar events for this week. We're talking May 5th through May 12th. And of course, ask more questions if you have them. Right now, actually, we're in the middle of the Eta Aquarian meteor shower, peaking after midnight, radiating from Aquarius, 10 to 60 an hour. The source is 1P Haley. However, we have a pretty big moon because May 5th, that's today, is the full flower moon. And there was an eclipse. Did anybody out there see that? It's National Astronaut Day. Okay, we have a comment from Janie. Yeah?
Well, according to the eclipse, all people really saw was a slight dimming of the moon.
Yeah, it wasn't a very exciting.
Well, it was through our penumbra.
Yeah. Yeah, there's kind of 2 regions Let's see what Janie has to say. I like your committee approach to review and answer the questions. A lot to learn and to distinguish the answers. Thanks for the demo. You're very welcome, Janie. I'm so glad you enjoyed that and you stuck around for it.
And if there wasn't such a delay in what you see versus what we say, and then getting you're writing your comments, I would have been asking you guys too, because
Yeah.
why not offload some of the brain power?
Well, and that's what they do. They actually have, what is it, like 15 to 20?
Collaboration, yeah.
15 to 20 different people look at every single image.
Mm-hmm.
So it's not just yours. And that takes the pressure off, I think, a lot. So May 5th is also National Astronaut Day and National Space Day. Of course, that's the first Friday in May, so that changes every year. And of course, there's a fun one, Revenge of the 5th. It's a reference to Star Wars.
And Cinco de Mayo.
Cinco de Mayo.
If you're in California.
Yeah, Cinco de Mayo.
If you're in Southwest U.S. or like one city in Mexico.
One city in Mexico
where they're actually celebrating Mexican Independence Day.
Yep, they fought off the French. And I don't know about anywhere else in the world. If you're in some other country, do let us know. I would be very curious to see if you celebrate Cinco de Mayo, which is a Mexican thing, but
which
nobody
is basically
in Mexico
here means drink Corona and eat tacos.
An excuse to have, So Revenge of the 5th, a Star Wars thing. Oh, I said that. May 6th is International Drone Day, and that's the first Saturday in May, another one that changes every year. And I had some confusion over this one. Maybe Dawn knows. International Astronomy Day, May 7th. But I got a couple conflicting answers on that. And I think it's twice a year, something like that. Anyway, so this is why I call the first week in May Everyday Spacer Week. May 9th, Uranus and the Sun are in conjunction. May 10th, Pluto and the Moon are in conjunction. May 11th, they kick off another Globe at Night project. That goes from May 11th to the 20th. It's 10 days total. In the Northern Hemisphere, you can look at either Leo or Bootes and report back what you see, take pictures, that kind of thing. You can use your cell phone for that. In the Southern Hemisphere, you can either choose Crux or Leo to take pictures of. And the Globe at Night project, they're trying to understand illumination in the cities, like how dark is it where you are, that kind of thing.
Yeah, basically it's all about dark skies.
Yes. Also the moon is at perigee. May 12th it's our Friday night show. I'll talk about that in a minute, but it's the last quarter moon. So next week, May 12th, we are going to do another profile. If you stick around for a little bit, I'll tell you who it's about. Find us Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page or the Everyday Spacer YouTube channel. Over to you.
Okay, so other events and activities. Everyday Spacer Week this year triggers the Everyday Spacer 2022 awards. We're taking nominations and we'd like a committee to help. Thank you, Cliff and Dawn, for helping us last year. We'll pick 2022 winners during World Space Week on October. Also, in the 2023 Humans to Mars Summit.
Oh, and I got to share that one.
Yeah. Is May 16th through 18th in 2023 at the National Academy of Sciences building in Washington, D.C. Oh, and yeah. Oh, here you want me to.
I can do it.
There it is.
Yeah, I just found out about this right before the show.
Yep.
So it looks like it's going to be a live and in-person event.
Yep.
Interesting how they have a range of prices.
Well, there's student pricing versus all the way up to you get mentioned in the flyer pricing.
That makes sense. Yeah. Well, they have sponsors too a lot of time.
Yeah.
So this is Explore Mars Inc.'s annual conference, the 2023 Human to Mars Summit, taking place, like Jeff said, May 16th through 18th, National Academy of Sciences building in Washington, D.C.
I wonder how many years they've had this national one, or
I don't know.
If it's the first year of a national one, that's a common.
I haven't even heard of this one before. Anybody out there? Have you heard of that particular event?
Yeah, because first time we did our science fiction convention, we billed it as a national or as a annual event.
Yeah, well, I say that too. First annual, so And the idea is we're going to do it every year.
Yep.
So if you or someone you know has done something interesting involving space exploration, science, astronomy, like that, we'd love to share our live.
Oh,
Join it. Yeah.
did we post the link for that?
Oh, for the Mars
the
one.
Mars one, yeah. Here, let me get that in.
You gonna do that?
Comments. Yeah.
All right. JD Becker says news to you.
Yeah.
Oh, the human to Mars event.
Yeah.
Yeah. Same here. So don't know.
Yeah. You're not close. Yeah. Well, yeah. You're just as far away from it as
we're not very close to it. So if you or someone you know has done something cool, let us know. We'd love to share our live. Next week we're going to talk about. I'm going to take on this one. We're doing a profile of Valentina Tereshkova, who was a cosmonaut and the first woman to travel off-world. She is actually still around. She's in politics now. So let's do a shout-out. Janie, thanks for being here. Dawn, thanks for being here. Shujaiji, hopefully I said that right. Thanks for being here. Scott, really appreciate you being here every single time. Dawn, thank you so much. And I think that's it. Mm-hmm. So, folks, have a really great week. We'll see you next Friday. Same time, same channel. Anything more from you?
Nope.
All righty. Take it easy. Good night.